Well, hello everyone. Thanks for being here at this time, either sober or inebriated. If you don't have a drink, the bar is right over here because blockchain is always better with alcohol. Well, drinking jokes aside, I'm Ali Haji Mirza. I'm a software engineer at the developer experience team here at Microsoft. And today I'm going to talk to you about how Azure and blockchain solved Webjet's reconciliation problem. Now, a bit of a history on Webjet. They are a travel booking company predominantly operating in the Asia Pacific. Now, throughout the years, Webjet has acquired other companies, and they've become a conglomerate. Now, all these companies were matured companies by the time that they joined Webjet, so they all have their own IT infrastructure and everything else that they need. These companies within Webjet do business with one another. For example, a hotel wholesaler will buy large blocks of hotels from hotel chains, and they will sell it to a hotel distributor or to a plane ticket seller. That's how you see when you go to buy a plane ticket, they will usually try to bundle it up with a hotel and a rental car and so forth. Well, there is one problem. At the end of the month, when these companies bring their bookkeeping records together, they always don't match. And they have to go back through their source of truth or their database, look at the records and see where this discrepancy happened and fix it. This process is very long and time consuming, and it's always expensive. And this happens every month. So there are a couple of solutions. One, a centralized solution that most of you are familiar with. You have an entity in the middle, which has a database and an API layer. All the other companies will talk to this entity to do business with one another. Well, this system also has a couple of flaws. What if the central entity goes down? No one can do business. What if they actually favor one party or another? And also, all these companies had their own IT infrastructure. If they put this in place, they have to fire essentially all those IT departments and come up with one. Well, there's also a better solution. There's a decentralized solution, which blockchain enables us to do. In this solution, everyone has a copy of every record, and they can do business with each other, even though if one of the parties go down, the rest of them can be fine. They can't also cheat, because if one of them changed a record, well, there's 7 other copies of it, so they would know. This also enables all these companies to hold on to their current tech stack while leveraging blockchain as a true source of truth as a side. So what does a blockchain solution might look like? On Azure, we have an offering right now that is the Ethereum blockchain protocol. This protocol has a pretty popular implementation that is in the Go language, and it's called Geth, short for Go Ethereum. We offer this on Azure, but the great thing is that your partners can run on any cloud infrastructure or on-prem that they want, and they can still talk to one another. Usually a blockchain solution has the Geth infrastructure, but you also have some way of talking to this blockchain. In our case, that's a web application. It could be a mobile application, or it could be a terminal application. One of the questions that we get usually is people ask, so what does a blockchain solution look like? And I tell them it looks like any other application that you've seen. Think about changing the database in the backend. Your users will not know what you're using. Blockchain itself cannot access the data that is not on the chain. For example, if you wanted to know the exchange rate between yen and dollar, there's no way to know it from the blockchain itself. But there are these programs called oracles that constantly monitor the chain, and they will react to it based on what is asked. So if you want to know the exchange rate, the oracle can go fetch that for you and then provide it. They also provide one other benefit. Usually the events on the blockchain stay on the chain. But if you wanted to use those events for something else, you need to have an oracle that is listening for those events. And for those events to be useful, we pump them to Event Hub, from there to a Stream Analytics job, and they can go to your web app for real-time communication. They can go to a storage, or they can go for they can be used for notification. Of course, you can always have Power BI dashboard for your system. Now, for the purpose of this talk, I'm just going to focus on the web app. And I even got rid of the UI layer to make it more simple to just show you what a blockchain solution looks like. But this could be a mobile application or whatever you want. For our demo, I'm going to be making a booking. It could be hotel, it could be plane ticket, it could be whatever you want on blockchain by writing a smart contract. Smart contracts are essentially blockchain programs. There are several programming languages that you can write these smart contracts in. One of the more popular ones is called Solidity. And I will use a JavaScript library called Web3 to interact with the blockchain. Yeah. All right. So the offering that we currently have on Azure, if you go under New, there is a blockchain category. And that is the first one, the Ethereum Consortium blockchain. The software is open source, but we take care of all the things that you have to do to set up this consortium. The network interfaces, the gateways, the storage that you need, or the compute. You can see one in action over here, a bunch of VM scale sets and whatnot. We also offer this really nice dashboard that is also open source, but we bundle them all together, that you can see the block propagation, you can see your difficulty, you can see who's mining, who's not, you can see what block you're on, and so on and so forth. All right, so to start developing for blockchain, you need to have that Geth instance running. This is one that is running, and it's synchronizing with Azure. So everything that exists on Azure, I will synchronize with it. And as you can see, I'm downloading one block at a time. Whenever a block is made, all the parties will get a copy of it. Jumping to Solidity, this is what a Solidity contract looks like. It is very like it likes a C program. You have a contract called booking. You have a bunch of class variables. You have addresses for buyers and sellers, and these addresses are unique addresses of the actors on the blockchain. Every actor, every contract will get its unique address on the blockchain that you can use to do transactions with. I also have the buyer price and the seller price. We will get into the notification system, but that's what the Oracle uses to interact with the chain. I have a very simple constructor that just takes a bunch of parameters, assign them to class variables. I have the update booking method that takes a price. But if you pay attention, there is a guard in front of this method which discards anyone who calls this function who is not a buyer nor the seller. So if their address don't match, we will terminate this. And why is that over there? Because as soon as this contract is on the blockchain, all the content of it, that is the data and the functions, are accessible to everyone who's on the chain. So first, you wanted to keep the data on the blockchain that you truly wanted to be public within your consortium. And also, you want those guards so no one can manipulate states on the functions that you don't want them to. Later on, I just assign the price that is being sent. If you're a seller, I update the seller price, and if you're a buyer, I'll update the buyer price. And we will make a notification so all the parties know that the contract was updated. I also have a contract state method that is a constant method. And if you look here, I don't have those guards because this function does not change data. So there's no reason to have that guard up there. It's simply returning true if the prices match, and if they don't, returns a false. Now, as far as Solidity, as far as Web3 is concerned, here's the JavaScript code for interacting with a chain. This is plain JavaScript. It is written in ES6, so if you're not familiar with the modern JavaScript, this might look a bit funky, but this is plain JavaScript. We are connecting to the blockchain or to the Web3 provider through an RPC host and a port. And I have methods such as unlocking accounts, which you need to do transactions. Deploying contracts, this takes the same parameters that our contract did. Updating booking takes a price and a contract. And here's where the Oracle magic happens, monitoring the chain. Given an address of a contract, you can monitor all the events that that contract is emitting. And if you're interested in the notification part, that uses a Solidity construct called event, which basically puts something on the log. And that function that I just showed will parse those logs and essentially will emit them through Event Hub to all the parties so they would be notified. All right, well, let's do a simple booking here. I have a buyer and a seller. All of my demos have been containerized, so all you need to do is just pull them down and you're good to go. You don't need to install anything. You just need Docker. All right, so as you can see, the buyer has a unique address, so does the seller, but they're both listening to the same notification contract. Those addresses are the same. All right, as a buyer, I'm gonna go give it a reference ID of ABC123, and I want it for $400. I unlock the account, send a transaction, and that hash that you see is the hash for the transaction that was sent. As soon as a miner on the blockchain network picks that up, it already happened, and mines that transaction, you get a contract address, which then you can talk to. And then I send another transaction to set my $400 price. Well, as soon as that one goes through, the Oracle will pick up the event and it will send it to all the parties that are listening on that. And that should take a couple of seconds. All right, here we go. The same information that I put in, seller address, seller has not put in a price yet. Buyer address, buyer price, my reference ID, and the contract state. All right, as a seller, you know what? $400 is just too little. I'm gonna propose $700. The same thing happens. I unlock the account, send a transaction, and as soon as that's mined, all the parties will be notified. Now I just wanted to show you something. I have another observer running here that doesn't act on anything, but they get all this information. So I cannot emphasize enough, what you put on the chain is public. There are ways to do private information on the blockchain. Those are beyond the scope of this talk, but if you're interested, please come talk to me afterwards. I'd be happy to help you. And here we go. This transaction comes in. The seller said, I want $700. I'm going to agree with it just to put the contract state in agreed. And this one was fast. They're both happy, and the contract is closed. Of course, they can go and update the contract again. But the nice thing is that all the logs are there, and no one will be able to change them. So if something happens, you can easily go back and play all those transactions to see what happened. And these are transparent, so everyone on the chain can see these. Yep. So today, I showed you what Webjet's reconciliation problem was, and I provided two solutions, which one most of you are familiar with, one you guys might not. We made a simple booking contract to do business on the blockchain. And what I wanted to talk about is blockchain doesn't really replace your traditional database and other systems. It merely complements it. You still need your caching layer, you still need your web apps, you still need your own database, but you can have this one on the side as a true source of truth that is being shared between all the parties. Now, while internet was great for sharing information, blockchain is great for proving ownership. I can put this dollar bill on the internet, and you guys can all download a copy of it, but it will lose its value simply because it was shared. But I can put this on blockchain, like a Bitcoin, like a cryptocurrency, and I can mathematically prove that that owns to me and to me only. And that's why that dollar bill will save its value on a digital world. Going back to our slides. Oh, perfect. We have a code story for Webjet published, or it will be published. But in the meanwhile, there are other code stories over there if you want to read them. I put all the demo material over there. We have a Get Started with Blockchain on GitHub. Feel free to follow me on Twitter or shoot me a message as email. I'm going to come back to the slide, so don't panic. Please fill the evaluation forms. And yeah, I guess I finished 4 minutes early. Thanks.